Hey guys, this is Sam here. Now I will be discussing about one of the important question, which is to find the order of this circuit without even doing any calculation in the interview. So what is the order of this circuit? It is basically the order of the differential equation that you write to solve the given circuit. Okay, so many of us would be thinking that the order of the circuit is just equal to the number of energy storing devices. Is it really equal to number of energy storing devices? No. So what is it then? So here I will be discussing some of the conditions that you should follow in order to find the order of the circuit. So there are two conditions. The first one being to check the flow of the current in this circuit. So for example, if you are given with a circuit that has two capacitances in series and a resistance and some other circuit here. So now if you see the I1 current flows through the C1 capacitance and the same I1 current also flows through these C2 capacitances. So here the order of the circuit is 1. Okay. So the thumb rule is if the capacitances have the same current flowing through them, then they are first order. If not, there is a high probability that the capacitance or the circuit is second order or any higher order circuits. Okay, in order to confirm that, there is one more condition, which is to find the relationship between the voltages of those capacitances. So if it turns out to be a linear relationship, then the circuit is first order. If you find out that the relationship between the voltages is a differential equation, then they are second order or higher order equation circuit depending upon the power of that differential relationship. Okay, now I will be discussing some examples to get you guys familiar with this approach. Okay, first we will go through this circuit here. So if you see the C1 and C2 capacitances are connected in series. So obviously if I1 current flows through this capacitance, then I1 flows through this capacitance also. So this circuit is a first order circuit. Okay, now moving on to this circuit here. If you assume I1 current flows through this, then here I2 and I3, you can say that I1 is equal to I2 plus I3. So definitely I1 is not equal to I2. So currents are not same in these two capacitances. So the first condition is ruled out. Now we need to check for the second condition, which is to find the relationship between the voltages of C1 and C2 capacitances. So we'll assume the voltage across this capacitance is VC1 and this capacitance as VC2. So now we'll try to write the KVL equation across this circuit. Okay, so Vin minus VC1 minus Vc2 is equal to 0. So Vn is equal to Vc1 plus Vc2. Now we have got the relationship between V1 and V2. So it is a linear relationship. So that brings us to the conclusion that this is first order equation or first order circuit. Okay. Now moving on to the other example. Now just consider this branch of this circuit. Okay. We'll assume the current flowing through this circuit is I. Okay, what are the different ways in which you can write I? We can write I based on this resistance and this capacitance also. Okay, based on that resistance, the current across the resistance is just given by V1 minus V2 divided by R2. So this same current flows through the capacitance as well. So in case of capacitance, the current can be written in terms of this formula, which is Q is equal to CV. When we differentiated with respect to time, this becomes I is equal to C times dV by dt. Okay, we'll assume the voltage across the capacitance as Vc2. So this I and this I is same. So which brings us to the relationship that this is equal to C times d Vc2 times dt. And if you rearrange these terms, you get V1 is equal to V2 plus R2C times dVc2 by dt. And now we have got the relationship between V1 and V2. V1 is just the voltage across this capacitance, so we can also tell this is VC1. Okay, if you see here, you have got a differential relationship of first order. Okay, so you just have to add 1 to the order of this circuit, and that gives you the order of the entire circuit. Okay, so here this is a first order, so add 1 to it, which gives us 2. So this is a second order circuit. Okay, even though if you see here there are two capacitance in this circuit, it turns out to be a first order, and in this circuit also you have two capacitances, but it turns out to be a second order circuit. So be careful with the finding of relationship between the voltages of the capacitances. Okay, this is the last example here. So now we'll assume the voltage across the C1 capacitance as VC1 and C2 capacitance as VC2. We'll write the KVL across this circuit. So the KVL is V in minus VC1 minus VC2. As these capacitances and the resistances are in parallel, the voltages across them is same. So which is VC1 and VC2 respectively. So which is equal to 0. So here Vn is equal to VC1 plus VC2. Same as that of the first example that we saw. So this is the relationship between VC1 and VC2, which is a simple linear relationship. So this is a first order equation, a circuit. Okay, so this is how you find the order of a given circuit. Just remember these two conditions, the first one being check the flow of current. If there is same current flowing through the capacitances, then it's first order. If it is not, then it might be a second order or any higher order. It might be first order also. So in order to make sure of the order of that circuit, we'll follow the second condition, which is to find the relationship between the voltages. If it turns out to be linear relationship, then it is a first order. If not, it is a second or higher order, depending on the order of that equation. Okay, thank you for watching this video. I'll meet you guys in next one.